Have you ever wondered what the SHA-256 hash sounds like? For most of you, I'm guessing the answer is no, of course not. At least, not until you saw the title of this video. For those of you who have never heard of SHA-256, SHA stands for Secure Hash Algorithm. It is used for things like storing passwords, processing cryptocurrency, and other things. It is a one-way function, meaning that you can put in input and get a result, but there is no known way to start with the result and calculate the original input. The 256 comes from the fact that the output is always 256 bits long, or 32 bytes. So where does sound come into this? Well, there are some videos on YouTube that give audio representations to different algorithms, either sorting algorithms, or in one case I saw the Mandelbrot set. I saw a couple of these videos and wondered if I could do something similar with SHA-256. I'll link a couple of these videos in the description in case you're interested. I split the task into a couple parts. The first part was to generate the data, and the second part was to create a sound file from that data. I did the first part in Python and the second in C#. Why did I use two different programming languages for this? Well, in Python, there were some ready-made modules that made the data generation reasonably simple. And C# is my preferred language overall, and I found a good example on Stack Overflow that told me the basics of how to create a wave sound file from within it. Okay, here's the Python script for the first part. As you can see, it's not very long, and I won't go into all the details, but the basic process is that it starts with the number 0, goes all the way to 30,000, and it converts the number to a binary form, puts that number into SHA-256, gets the output and converts that back to a number. And so the maximum value for this is 2 to the power of 256, or approximately 1.2 times 10 to the power of 77. Okay, so it adds each of those values to a list of numbers, and then down here it will create a graph of those numbers, and also create a spline between the numbers. I'll go ahead and run it so I can explain it a little bit better. Okay, so here is the output graph. And I'm going to zoom in here to a very small sliver. All right. Let's actually zoom in a little bit more. Okay. This first bit is just some buffer I added to even out the wave. So each of these points are the representation of output values from SHA-256. And I used a spline function to generate waves along them, because sound is in waves. And so the final output file will actually contain a number of points along these wave lines so that we can have a legitimate sound representation of the data. So this also produced this file here, and this has all the output data. Now the values have been scaled from the original when this graph was produced, because these values are far too large for use in sound. So it's compressed vertically and stretched horizontally to make the final output. Now let's go into the C# project, and if I were publishing this as an application, then I would of course make it so you could choose any file you want when running the application, but for now I just put the file path directly in here. So this first file simply runs the program and reads the data from that output file from Python. And then over here, this does all the actual sound file generation. So it writes the file. I'll go ahead and run that. And it's all done. And over here we have the output file. Okay, so I can open this in any audio player. For now, I'll just, I'll open it in good old Windows Media Player just to demonstrate. Okay, you get the idea. So now, to make things a little more interesting, I'll open it in Audacity, which is a free sound editing software, and it allows you to see the waveform. So let's zoom in to this sound file. Zoom way in here. All right, so you can see the waveform of the sound here, and let's compare that to our graph. Let's see. Okay, let's stretch this out a little more. Shrink it down this way. And look at that. We've got these three lumps here, got this thing, etc., etc. So we have effectively made this graph into a sound wave, which I think is pretty cool. So we can play it here. And you get the idea. Now, just for fun, there's a little app I use called OnPitch, which shows me the pitch of currently playing audio. And as you'll see, SHA-256 is all over the place. Small side note, if I end up making a game that needs a Windy Canyon sound effect or something similar, I may just use SHA-256 for that. Alright, I hope you enjoyed this video, and without further ado, here are the first 30,000 values of SHA-256 represented in audio form.